So hi guys, how are you doing? So hello Raj, how are you? First of all, let me welcome you guys to the Unacademy JEE English. This, as you know, is a brand new channel by Unacademy where every concept of physics, chemistry, and maths are being taught to you completely in English. Now, this is a series that I host for class 12 students, and the topic that we're discussing right now is ray optics. This is lecture number 5 of ray optics, and today we'll be talking about refraction of light. Now, before we get started with today's discussion, let me introduce myself for those of you who might not know me yet. So my name is Rohit Dixit and I studied mechanical engineering from IIT Delhi. Okay, so just a second. Okay, so here we go with my introduction. So I studied mechanical engineering from IIT Delhi and for almost past 8 years I've been teaching physics for the IIT JEE exams, both mains and advanced, and I've been doing this in the offline setups. Offline, I've been associated with some of the topmost institutes, in the industry of IIT JEE coaching. Okay, now, hello Mahi, how are you? Hi Rajesh. Now, I myself was All India rank 447 and All India rank 1 and 2 in the two stages of the ITJ exams that I took. I also qualified at the NTC Stage 2 examination and I was in the top 1% in the NSCP as well. Now, I've already coached many students to top ranks in the ITJ in my offline experience. And here I am now to guide you guys through this online mode to your dream colleges and dream ranks. So how can you guys make sure that in this time also, where you most of the people do not are not getting access to any kind of good guidance and education, so you can get yourself the Unacademy subscription. This subscription will give you benefits like live classes where you get to interact with your educators on a regular basis, and of course these classrooms have live polls and leaderboards. You also have test series and analysis, which again keep you on your toes and keep you aware of your standing in the competition. And of course, you have live doubt clearing sessions, which ensure that your doubts do not pile up. Okay, so yes, hi Ananya. Sir, when are you starting quick review of SHM and waves? So Ananya, I'm doing that from this Friday. Okay, this Friday we will have quick review of SHM and then waves. Okay, so Friday, Saturday, Sunday is when you can expect the quick review of SHM and waves. Okay. Next, on top of all these benefits that I mentioned, you also get the opportunity to study from the topmost educators all across India from the comfort and safety of your home. So that I think is a wonderful opportunity. It's a great chance for you to keep learning from the best, okay, from your home, okay. Next, so how do you get these benefits and how can you ensure that your studies are going on smoothly? So the first step is to install the Unacademy app. The moment you do that, you realize that you'll unlock yourself a lot of features which are available for free on the Unacademy app. So these include free courses. So there are a lot of free courses that are running on the Unacademy app. For all these to join these, all you need to do is just install the Unacademy app. So hello Amod Kumar, how are you? Then, of course, you have special classes. Again, anybody who has installed the app can attend these special classes. So I keep posting these special classes. So the next special class is going to be tomorrow and day after tomorrow. Okay, so you can join me for those special classes. And then you also have quizzes like the one we just have. So all these features you can avail just by installing the Unacademy app, and to unlock these features, you can use my code RD Live. Okay, so use this code and unlock all these free features. So these features you'll be able to access without even having to buy the subscription, just by installing the app. Okay, so go ahead, make sure that you are doing that at least. And so what that does is that gives you an idea of how your plus subscription is going to be like, how your studies with the plus subscription are going to feel like. So if you like that, then you can finally decide to buy the plus subscription, and this is how you go about that. So you can go to the plus section of the app, select your goal as IITJ, and click on that get subscription button. When you will do that, you will be redirected to the payment page where you will find a box which will say, do you have a code? So remember, that is where you can use this code RD Life. You use this code and you will get a 10% off on all your subscription fees. Okay. So now you can choose from the plus subscription or the iconic subscription. The plus subscription and iconic subscription cost these amounts for 6 months, 12 months, and 24 months. Okay, and you will also realize when you click on proceed to pay, then you have a lot of no cost EMI options to choose from, wherein you can break these payments into a lot of no cost EMI options, which will definitely reduce the burden of the payment in one go. Okay. Next, you most of you guys know about the plus subscription, but don't know about the iconic subscription. So let's tell you a bit about what the iconic subscription is all about. So this iconic subscription will take your ITJ preparation to the next level with personal coaches. So from our team of experts, you will be allotted personal coaches who will closely guide you and mentor you throughout your ITJ journey. You will also be attending a lot of ITJ workshops, receiving timely expert guidelines, getting a study planner. Again, I think which this is very important. A lot of students I know could use this. Okay, and then you have regular text analysis sessions. So those students who feel that they will perform better if they get more personal guidance, then they should go for the iconic subscription. This is what is meant for you. Okay. Now you for all you guys who are going to their class 11 and looking for a single one-stop solution for all their preparations and studies for the next 2 years, can go for combo subscriptions. Okay. So there are 4 combo subscriptions available, which will ensure that your preparations for IIT exams, your preparation for class 11 CBSE, and for your class 12 CBSE, your boards, everything is taken care of with a single subscription. So the first combo offers the iconic subscription for IIT JEE preparation and the plus subscription for CBSE class 11 and 12. And this subscription starts at roughly 4,600 a month. Then you could have gone for a combo subscription which offers all 3 iconic subscriptions. This one starts at 5,500 a month. Then, of course, you can go for a combo subscription where you get all the plus subscriptions. This combo starts roughly at 3,000 a month. And then you have the combo where you get the IIT preparation with plus and the iconic for 11th and 12th. And this one starts at roughly 3,900 a month. Okay, so you can choose a subscription that suits you better, that suits your preparation, and now can don't have to worry about any of your studies after your class 11th for your class 11th and 12th. Okay. Next, these are the upcoming tests in January, so make sure you're not missing out on these. Okay, so you can take part in the Unacademy Combat, which is going to happen next on the 17th Jan and on the 31st Jan. Now, race, this has already happened. The next one is on the 24th of Jan. Then there is Last Mile. Again, this has also happened. Then you have AIM Advanced 2021, which happens every Saturday, and then you have Unique, which is DPP solution discussion, which happens from every Monday to Thursday. Okay, so make sure you're not missing out on these. Okay, now those of you who are following us on the JEE English channel of YouTube can connect with us on the Telegram app also using this link. Okay, this will make sure that your studies are going. You are getting all the notifications of all of the sessions and lectures happening here on the Unacademy JEE English channel, and so that you're not missing out on any of it. Okay. All right. So why don't we get started with today's lecture then? As I told you, this is lecture number 5, and today we'll be talking about refraction of light. Now, before we get started with today's lecture, let's start with the problem from from our discussion of the previous lecture. Okay. So if you remember, in the previous lecture, we were talking about curved mirrors and about the images formed by curved mirrors and how to find the velocity of the image and the object. Okay. So here is a question for you to practice. So this question says, a concave mirror of radius of curvature 20 centimeter and an object are placed at a distance of 15 centimeter along the principal axis. Now both are moving with velocities of 1 meter per second and 10 meter per second as shown. You to find the velocity of the image. So that is how the object and the image and object and the mirror are placed and they are moving. Okay, so look at the image and try to find the velocity of the image. Okay. So again, you should remember this. This we discussed in the last class. So if you paid attention, this should be easy to solve. Okay. Let's see if you can figure this out. Okay. So where is the object placed? So object, you will realize, is between F and C. Where will the image be? Image, of course, would be between 2F and 2C. Let's see if you can find the answer for this. Okay, guys. So hurry up. Let me know if you're trying again. You can always write trying in the chat so that I know you guys are trying this. Okay. So remember the discussion that we had a day before yesterday, and try to analyze this. So till the time you guys are trying to figure this out, let me help myself with some water. So hurry up. Let's see if you remember this. Okay. Yashaswini says, "Sir, I'm new to this channel." So most welcome, Yashaswini. What class are you in? What class are you in, Yashaswini? Okay, so we are discussing ray optics. This is ray optics. Okay, and today we are talking about refraction of light. Okay, I'm sure you can read the title of the lecture also. Okay, so you are in class 12. Great. So for you, you can attend these lectures, and you can also attend a series that I'm hosting, which is called the Quick Review, which in which we quickly revise class 11 topics. 11th topics are reviewed quickly. Okay, so you can attend both these. Okay, AP says 45. Mahi also says 45. All right, let's see. Let's see if that is correct. Hmm. Okay. So of course, you know the relation of how to relate the velocity. You know 1 over v plus 1 over u equals 1 over f. Correct. Okay. So if you differentiate this, then if you remember from this we had found that du over dt times minus times v square over u square, that is equal to dv over dt. Okay, I hope you remember that. This is the result that we had gotten in the last class. Okay. All right. So all of you guys are saying 45. So let's hope that is correct. Now what I need to do is first let's find out the v. So I know 1 over v plus u obviously is minus 15. Okay. So I'll say 1 over minus 15 should be equal to minus 1 over 10. Okay. So the radius of curvature is, you realize r is 20. So f would be 10. R is r by 2. Okay. So, and because this is a concave mirror, so the focal length would be taken as negative. Okay, so that will tell me that 1 by v equals 1 by 15 minus 1 by 10. Okay, so what I'll get is v equals 150 over 5 with a minus sign. Okay, so this is what I'm getting my v as. Okay, now you know dv over dt should be equal to minus times v by u whole square. So 30 over 15 whole square times. Now the speed which is related to in reference frame of the mirror. Okay, we will take the speed in the reference frame of the mirror. In the reference frame of the mirror, you will realize that the object would be moving with a speed of 11. Okay, so please note that this expression is true in a reference frame of the mirror. So I will go into the reference frame of mirror, wherein I will get in the reference frame of the mirror, my speed comes out to be 44 meter per second with a negative sign. Okay, so negative sign means that the image would be traveling in this direction. Image would be traveling in this direction with 44 meter per second. So of course, this is the speed of the image in the reference frame of the mirror. So speed of the image, velocity of image with respect to ground is velocity of image with respect to mirror plus velocity of mirror. So that will make it 45 meter per second towards left. So that is the right answer. Very well done, all you guys. So I'm very glad that you remembered this discussion and you figured this out. Well done, people. Okay, proud of you. So proud of you. Okay, great. Again, I hope that is clear to all. So 45 is in fact the right answer, and the direction is towards right. Okay, because the object was moving towards left, so the minus sign indicates that the image would move towards right. Okay. Okay. All right. So if that is clear, let's move on to the next part. Now we will. There is a small matter that we need to discuss about mirrors. Again, what happens if you cut the mirror? Now, any part of the cut mirror behaves like a complete mirror, and the image formed through various cut sections will be as follows. So imagine that you have a mirror like this. Okay, so obviously you realize this would have formed one image. Now, even if you cut this and if you place half the mirror, then this half mirror also behaves like a complete mirror only. Okay, it would behave as if it was a complete mirror. Okay, and you will realize that the image will be formed exactly same as the image was formed here. Okay, see why is that happening? So imagine if there was any object, if there was any object here, then if there was image getting formed here, so you can find two rays going like this, which will give you the image. Okay, now you could have had diametrically opposite rays also. Now all that is happening is these rays are not reaching. Okay, so the rays below are not reaching, but the rays above are still reaching. So what will happen is that you will see an image, you will see an image here, even with this half the mirror. However, but the intensity would be half. Okay, because only half the rays are converging. So number of image formed is one, but intensity reduced by half. Yeah. So the image will not be as bright as the original image, but you will still have the image at the same location and one image only. Now, similarly, if you removed such a section from here and you had this, then again you will have one one image only with some reduced intensity, because all the light rays which would have incident on this area are not getting reflected back. Okay, so the intensity is getting reduced. However, only one image is formed. Now, on the other hand, if you take a look at this, so if you cut the mirror in two parts and if you shifted them, then what you will realize is that this mirror will behave like a complete mirror. This will also behave like a complete mirror. So now you have essentially two mirrors. Okay, that is what the system will look like. The system will appear as if you have two mirrors. So if here is your object, you will have two images, one here due to this mirror and one here due to this mirror. Okay, so in this case you would have had two images. Okay, again, so for these what you need to do is complete the imagine a complete mirror with its principal axis. Okay, and form the two images from the two mirrors. Okay, so this is very simple, but you should just remember this. Okay, so if the mirror is cut such that the principal axis remains unchanged, then you have a single image form. If the mirror is if the mirror parts are shifted after cutting the multiple if after cutting, then what happens is both the principal axes have been shifted. So these will behave like two mirrors and you will have two images. Okay, again this should be simple. Next, we can also find the field of view here also. Okay, for curved mirrors, again the technique of finding the field of view is exactly the same that we did in our plane mirrors. Okay, so if imagine an observer was here. So let's imagine an observer was here. So instead of an object, or you could have had the object also. So all you need to do is figure out the rays reaching the end, going to the end of the mirror and reflecting from here. So you realize every if this is the extreme in which the light rays going out from the object are fanning out. So this entire region would be the field of view. So any rays coming or falling to the mirror from this region would be visible to this observer. Okay, so this is what we define as the field of view of this for this observer. Okay, again you won't have too many questions on that. Okay, now let's start with our discussion of refraction of light. Okay, so here is a very cool image of a refraction which I really like. That is why. So you see a light ray, a laser ray, in fact, which was going in this direction. Okay, bends like this when it moves in a glass slab, and then bends again as it moves back to air. So that is what refraction is. Okay, that is what we are going to study next. So refraction is the deviation or bending of light from its original path when it passes from one medium to another. Okay, that is what we call refraction. Again, another example here. So whenever light changes medium, you see that it usually bends from its path. Okay, otherwise it moves in straight line paths. If that straight line bends, then that must be happening due to change in medium, and that is what you call a refraction. Okay, so this change in path is due to the change in speed of light as light passes from one medium to another. So light moves in different mediums with different speeds. You should already know that. So whenever the speed changes, we notice that the direction also changes and there is a bending that is happening. Again, we can explain this using Fermat's principle also, okay, which we will in a bit. Okay. Now the bending of this light depends on something that we define as the refractive index of the medium. Okay. So what is refractive index? Refractive index of any medium is defined as the factor by which the speed of light reduces as compared to the speed of light in a vacuum. Okay, so for any medium, its absolute refractive index is defined like this: C over V, where C is the speed of light in vacuum and V is the speed of light in that medium. Now you can also have relative refractive indices. So relative refractive index is defined as the ratio of two refractive indices. Okay, so what it will be? So it will be V2 over V1. You will realize, which will be the ratio of the velocities in the two mediums. Okay, so that is what you call a relative refractive index. So you can define refractive indices in two manners. So relative, which means refractive index of medium one with respect to another, which is defined as the ratio of the two refractive indices. When the refractive index is defined with respect to vacuum, then you call that the absolute refractive index. Okay, so remember this. Then we'll move on to the laws of refraction. And again, there are two laws of refraction which are as follows. So first law says the incident ray, the normal, and the refracted ray all will lie in the same plane. And again, you can see from here. So all these three will lie in the same plane. You should know this is the incident ray. This now is called the angle of incidence, the angle between the normal and the incident ray. This is called angle of refraction, which is the angle between the refracted ray and the normal. So all these three, this ray, and the normal, all of these will always lie in the same plane. And of course, then you have another law which says that sine I over sine R is always constant for any pair of medium, okay, for a light of a given wavelength. Okay, now this is known as Snell's law. Again, you guys must have studied this earlier in class 10th also, so a lot of you must be aware of this. So this law says that sine I over sine R equals N2 over N1, where N2 is the refractive index of the medium 2 in which the light is going, and N1 is the refractive index of the original medium, or you can also say it is equal to V1 over V2, where V1 is the speed of light in medium 1 and V2 is the speed of light in medium 2. Okay. Now, sometimes, most commonly, we also write it in form of this. N1 sine I equals N2 sine R. So, the refractive index of the medium in which the angle of incidence is formed into sine of I equals the refractive index of the medium in which the angle of refraction is being formed into sine R. And that is always constant. Okay. This is always constant. Okay. Even for multiple refractions, we will discuss that later. Okay. Now let's try and prove this using Fermat's principle. Okay. So again, I told you everything about ray optics can be proven through Fermat's principle, right? So let's imagine there is a boundary here, and you have medium one here, okay, and you have medium two here. Let's imagine that light has to travel from point A, which is somewhere here, to point B, which is somewhere here. And I told you, light always takes up a path which is the path of least time. So I don't know where it should hit, what kind of path it should take. Let's assume a few things. Okay, let's assume a few things. So let's say that this height is y1 and this height is y2. So this is the distance or the distance of the points from the boundaries. And let's say that this entire length is some d. This is the distance, horizontal distance between the 2 points. Now let's imagine hypothetically that a light ray comes and reaches the point like this, and then it moves to point B like this. So this appears pretty straight only. Let's not have straight lines. Okay, so let's try and draw a more curved line. Okay. So wait. All right. Let's imagine that a light ray comes and hits here and then goes here. So yeah, here it is bending. Okay. Now let's imagine that this is x1. This of course is some x2. So let's take a note of the length of the path covered by light. Okay. So if you notice that, what do you see? Let's see. So you realize the length of the path covered in medium one is this. Okay, this is being covered with speed v1, and then in length in medium two you have this length. Okay, so let's give these names. Okay, let's say that this is L1. This is being covered by a speed v1, and let's imagine this is L2. This is being covered by a speed v2. Okay, so all I need to do is find the time that light took to reach from A to B, right? So time taken for a light to reach from A to B. Let's see how much of that is. So that will be T would be equal to L1 over V1 plus L2 over V2. Agreed? This should be simple. Again, so the Y1 and Y2s are fixed. What is independent? What I can choose is X1 and X2. I can choose where the ray hits, and I can vary that. And if I want to vary that, and if I want to see what will ensure the minimum time for light to reach from A to B, let's see. Let's write L1 in terms of x1 and y1. You will realize L1 can be written as root of y1 square plus x1 square. Okay. Similarly, L2 can be written as root of y2 square plus x2 square. Correct. Now, x2 can also be written as b minus x1 because b is the total horizontal distance between points A and B. So I can write t as root of y1 square plus x1 square over v1 plus root of y2 square plus d minus x1 whole square over v2. Correct? So to find the minima of this, all I need to do is x1 is the only variable that I control. Okay, y1 is fixed, y2 is fixed, the speeds are fixed. Okay, I can change x1. Okay, whenever I want, however I want. And let's see how the change in x1 affects my time. Okay, let's see. So to find the minima, I can find a dt over dx1 and put it to 0. Okay, all right. So dt over x1, what will that be? So I will get a 2x1 over v1 root of y1 square plus x1 square 2. Okay, I hope you guys can see that. This is the result that you'll be getting. Okay, then for the second part you will get minus 2 times d minus x1 over 2 times root of y2 square plus d minus x square. Correct? Right, now let's add a page and go ahead. Okay, no, I have left. So, great. So now all I can say is for minima, I can say that dt over dx1 should be equal to 0. Right? So that is what I'm trying to get to. Okay, so if I do that, let's see what I'm getting. Then I am getting x1, okay, x1 over root of y1. Here I have y1 square plus x1 whole square equals 1 over 2 times b minus x1 over root of y2 square plus x2 square or x1 square. Correct? Please take a look. This is what we are getting. This 2 and this 2 is getting cancelled. This 2 and this 2 is getting cancelled. Now, if you look at this, now focus on this term. Focus on this term. This is essentially x1 over L1. Agreed? So I'm getting x1 over v1 L1 equals, and how about this? This is x2 over L2. Agreed? Now let's take a look at this triangle. Let's take a look at this. Okay, so here this is 90. If this was I, this would also be I. Okay. Similarly, if I take a look at this triangle, if this was R, then this was again R. So in these triangles, let's take a look at x1 over L1. So x1 is this. Okay. Pay attention to this now. This is important. This is where you get the answer. This is x1. This is L1. So x1 over L1 is nothing but sine I. Right? Similarly, this is your x2 and this is your L2. x2 over L2 is sine R. Right? So if you substitute these values, what you are getting is sine I over V1 equals sine R over V2. So here you have Snell's law. It says sine I over sine R to be equal to V1 over. So that is your proof of the Snell's law using Formas principle. Okay. So let's talk about this. This is what we studied here. Sin I over sin R equals V1 over V2. Okay. Now you can see the proof of that. Okay, I hope that is clear to all. Okay. So again, try and go through this. So we use the Fermat's principle. We said that the light will take up a path so that the time taken to reach from A to B is minimum. Okay, and that does give us the result of the well-known result of the Snell's law. Okay. So just take a look at this and let me know if there is any confusion. Okay. So here was the proof. So this is what we did. Okay, we found the time taken from light to reach from A to B. Then we differentiated it to find the minima, and the condition for minima that I'm getting is sin I over sin R equals V1 over V2, which is our Snell's law. Okay, so here is your proof for Snell's law. Again, you don't need to remember this proof, but you should remember Fermat's principle definitely, because you might have to use that in some problem solving. Okay. All right, and now why don't we try a few problems from the refraction. So here is a practice problem for you. This problem says that a light ray is incident on a glass sphere at an angle of incidence which is 60 degrees as shown. Now all you have to find is the angles R, R dash and E and the total deviation after fractions. Okay. So let's talk to you about the deviation also. Okay, so let's we add one page and talk about the angle of deviation. That is something that I haven't talked about, right? Let's quickly discuss that also. Okay. Let's talk about angle of deviation. So again, you guys should know what is the angle of deviation. Angle of deviation is the angle by which the light deviates, okay, during a process. So for reflection also we defined those. So imagine this was the boundary of the medium and this was the light which was coming. Okay, light ray was coming like this. Okay, and imagine this was the normal. Okay, and this is how the light bends. Becomes like this. Okay, so you realize this is the angle I. This is the angle R. So what will be the original path of the light? Let's try and draw the original path. Had it not encountered that medium, so this would have been the original path. So by what angle did the light get deviated? So you will realize that this is the angle of deviation delta, and delta would be I minus R. Okay, so that is the angle of deviation suffered by a light ray during refraction. Okay, I hope that is clear. So I can say from the ray diagram, we notice that the angle of deviation is delta equals I minus R. Now remember this. This is a very important result. Okay. The angle of deviation after a refraction is I minus R. So now let's try this. So you have to find the angles R1, R dash, and E. E is called the angle of emergence also. We sometimes call E as angle of emergence. It is the angle at which the light ray emerges. So that is why the symbol E. And you have to find the total deviations after these two refractions. So a light is suffering two refractions, once when it enters this solid glass sphere and one when it exits. So you have to find these angles. Okay, try this, try this. Let's see. Okay. So again, this is a very easy one, guys. Let's see. Let's see if you can solve this. Come on, people. Let's get some answers. Okay. Yes, AP. It is pretty simple, of course. So AP says 30, 30, and 60. Okay. Yes, it does appear that simple in fact. So let's take a look at this. So you know this the line joining the center, this would be normal. So this is the angle of incidence I, and the angle of refraction for first surface is R. So what you realize is you can apply Snell's law. Okay. So I can say from Snell's law, what you can say is N1 sine I equals N2 sine R. This is the most common form that we are going to use. Okay, remember this. Stick to this. Okay. So N1 is 1 into sine of 60 to be equal to N2 is root 3 into sine of R. So you realize sine R is 1 by 2. Okay, sine 60 was root 3 by 2, root 3 would have gotten cancelled. So what you realize is R equals 30 degrees. So absolutely correct, AP. Now you will also realize if you take a look at this triangle, look at this. So in this triangle, this side is the radius, this side is the radius. So this is an isosceles triangle. Okay, if this is an isosceles triangle, so you can say that R would be equal to R dash. Okay, so next I can say also from geometry. Also from geometry, R is equal to R dash, which is equal to 30 degree. And once you have R dash as 30, then you also know that the angle of emergence obviously would be 60. Okay, because you will have a similar equation as this. So E would also be 60. So very well done, AP. All your answers are correct. Congratulations. Now, how about the total angle of deviation? What about the total angle of deviation? So let's talk about that also. No? So what is the angle of deviation in case number one? Delta 1. Delta 1 is 60 minus 30. Okay, so that is 30 degrees. And from here, you will realize the light again turns by 30 degrees. Delta 2 is also 30 degrees. So delta total would be 60 degrees. 60 degrees is the total angle of deviation after two refractions. Okay, I hope that makes sense again. Okay, now let's try another very nice interesting problem. And this is a very standard problem as far as your refraction is concerned. So you've been told a cylindrical vessel whose diameter and height of both are equal to 30 centimeter is placed on a horizontal surface, and a small mass P is placed at a distance of 5 centimeter from, this would be from the center. An observer is placed such that the bottom of the vessel is just visible to him. Now, to what minimum height should water be poured in the vessel to make P visible to the observer? Given to you is that refractive index of water is 4 by 3. Again, a very standard question. Okay, so let's see how you would solve this. Diameter and height both are 30. Okay, so if both are 30, this angle you would already know is 45 degrees, right? This would be 40. This is 30. This is also 30. Okay. Now what you want is imagine. So I'll help you with this one. Okay, just in case, because this is the first question, first slightly tricky kind of question that you are encountering. So I'll help you with this. Let's imagine that form I fill up water to till some height h. Okay, let's assume that. Then what I want is that any light ray going from here after refraction should go along here. If that is what happens, then then the observer would be able to see P. Okay, I hope you realize that. Now you realize that this distance would be 50, right? And this distance has been told to you as 5. So let's say that here this is h. Now let's assume that this distance is some x, and this is also, you will realize that if this is x, again if this is some y, then this will also, okay, why? Because this angle would be 45. Okay, now all you need to do is find the angle of incidence, which is this. I find the angle of refraction. Angle of refraction is obviously going to be 45. Okay, so if you can find the angle of incidence, then you're done. Okay. I hope you guys are following the geometry. Think about this. Think about this first. Then let me know. You are following the geometry. Okay, should we start writing the equations? Okay, since I know the angle of refraction R equals 45, so I can find I. My angle of incidence should be 4 by 3 times sine I should be equal to sine of R, 1 times sine of R, which is 1 by root 2. That gives me sine I equals 3 by 4 root 2. Okay. If that is the case, I know my sine I in R is okay. So let's see. How much will this x be? X plus y I know. I also know x plus y would be 15. And sine I would be perpendicular for the hypotenuse. So sine I already know. I know tan I would be equal to 15 plus x, 5 plus x over h. Correct. I also know x plus y equals, and I also know h plus y equals. So I have these three equations. Okay, with the three unknowns. Okay, now using these I will solve those. Okay. Three equations, three unknowns, so I'll be able to solve these. This is how we get the height h. Okay, all right. This is equation one, this is equation two, this is okay. Solve these three equations and find all these three variables. All right, then you have critical angle and the total internal reflection. Now, what you notice is that if obviously imagine if light ray is traveling from denser medium to a rarer medium. So what do you call denser medium? Denser medium is one for which mu is higher, and rarer is one for which mu is lower. So what you notice is that whenever light moves from denser medium to rarer medium, it bends away from the normal, or the angle of refraction is greater than the angle of incidence. And when it's the other way around, then of course the angle of refraction is smaller. Okay, so I can say when a light moves. Okay, when I say denser and rarer, I am talking about optically denser and optically rarer. Okay, moves from an optically denser medium to an optically rarer medium. It bends away from the normal, right? Or I can say R is greater than I. Right? The angle of refraction increases. And how does that happen? You also know if this was in one, this was in two. So sine I be equal to 2 over 1 sine R. Okay. Or I can say sine R is equal to n1 by n2 and I. Now you realize because we're talking about formula for TIR. Yes, yes, Gani. So I'm trying to tell that only. So what you realize is that since this is sine, this has to be always less than equal to 1. But you do realize that mathematically this expression can take up a value greater than 1, right? So what happens then? So then something different happens as you keep on increasing the angles of incidence. So you realize the sorry At one point, at one point, the angle of refraction will keep on increasing, right? At one point, the angle of refraction becomes 90 degrees. And if you increase the angle of incidence beyond this, then the surface starts to completely reflect the light back into the denser medium. Okay, so that is what we call total internal reflection, as rightly pointed by Gunny. Okay, so we realize at one point. Okay, so let's just add. Okay, I have to have. Okay, to explain that. What I can say is at a certain eye, at a certain eye, sine r equals 1, which means r equals 90 degrees. Okay. Now you realize if you increase the I further, then the sine r value would have gone to be more than 1, which is not possible. Okay. Now this I is called the critical angle. This I is called the critical angle. Okay. Now if the angle of incidence is increased beyond this, if I is increased beyond this value, then the incident light, the incident light gets completely reflected back into the denser medium. Right now, this phenomena is called total internal reflection. Total internal reflection. The word total means that it will be completely reflected. Now, even when a reflection is happening through mirrors, what you will notice is that there is not complete reflection happening ever. Why? Because what happens is if you have a light incident on a mirror, then what you notice is that the intensity of the reflected light is always slightly lesser. Why? Because some part of the light would be absorbed by the mirror itself. So that is why in any kind of reflection that you see from your mirrors, the complete light is not getting reflected back, except for here. Here it is total internal reflection because the 100% intensity of the incident light gets reflected. Okay, and the critical angle obviously can be found out using this condition. So IC would be sine inverse. You can realize from here that it would be N2 over N1. This is called the critical angle. You can calculate this. If the angle of incidence exceeds this critical angle, then you get total internal reflection. Now, total internal reflection turns out is a very, very extremely useful thing, and we will talk about this in detail in the next class again. Okay, this is where I would like to wrap up today's discussion because we have run out of time for today. Okay, and before I leave you, let me remind you that if you haven't gotten your Unacademy subscriptions and if you're planning to, then this is how you do it. Okay, you can go to the plus section of your app, select your goal as IIT JEE, and click on the get subscription button. Okay, now when you do that, you'll be redirected to the payment page where don't forget to use the code RD Live. Okay, so this code will give you a 10% off on all your subscription fees. All right. Now you can also choose from the plus subscription or the iconic subscription. Of the fees for both of them are mentioned below. Okay, now you will also realize when you click on proceed to pay, you can also choose from a lot of no cost EMI options to make this payment so that you don't feel the burden of this payment. Okay. Now, a lot of you don't know what the iconic subscription is, so let me tell you a bit about that. So, the iconic subscription, of course, takes your IIT JEE preparation to the next level. with the help of personal coaches. So with this kind of subscription, you are allotted personal coaches from a team of experts who will closely guide you and mentor you throughout your ITJ journey. And of course, along with that, you'll be also attending a lot of ITJ workshops, receiving timely expert guidelines, getting a study planner, which I think a lot of students need, and having regular test analysis sessions. Okay, along with these benefits and the personal attention of your personal coaches, it will your JEE preparation will definitely go to the next level. Okay. Now, for all the students who are going to come to their class 11th and looking for a one-stop single solution for all their studies, for their class 11 CBSE, for their class 12 CBSE boards, and for their IIT Mains Advanced. So you guys can go for these combo subscriptions. So there are 4 combo subscriptions available. The first combo subscription offers you the iconic subscription for IIT and plus subscription for 11th and 12th. This subscription starts at roughly around 4,600 a month. Then you have the second combo subscription that you can go for. This combo offers you the iconic subscription for ITJ and as well as your class 11th and 12th CBSE. This combo starts at 5,500 a month. Then you can have a combo where all the 3 are available for plus. This combo starts at roughly around 3,000, and then finally you have the combo where you get a plus subscription for ITJ and the iconic subscription for your class 11th and 12th, and this subscription gets to you at around 3,900 a month. So hello ARJ, how are you? How have you been? Uh, also, let me just inform you quickly about the upcoming tests in January. So these are the important tests and the important dates. So mark them in your calendars. Do not miss out on this. So next Unacademy Combat is going to happen in January on the 17th Jan and the 31st Jan. Then you have race. So this is already over. The next race test is on the 24th of Jan. Last mile target is already over, which was on the 9th of Jan. Now you have AIM Advance 2021, which is happening every Saturday. So make sure you're taking part in that and getting yourself some good practice, last minute practice that is needed. And of course, you have unique DPPs, so which are getting discussed every Monday, Thursday. Okay. Next, if you like today's video, do not be lazy. Press that like button and share it with more and more people so that many students can benefit from this high quality, completely free educational content being provided here on this channel. Okay, make sure that others are also benefiting like you. So don't forget to press the like button and share it with as many people as you can. If you're new to this channel, then don't forget to subscribe to this channel, and don't forget to press the bell icon. A PDF of all the slides used in today's lecture would be available to download very soon. Okay, so ARJ seems to have a long comment. Okay, I'm trying my best to cross 99 percentile marks, approximately 160 in Feb Mains, and I'll skip March and give the next one in April, by which I will be done with at least 90% of the syllabus. Is that better or not? Yeah, of course. That is definitely better. Sounds like a good plan. Go ahead. Good luck. Okay. All right. Finally, those of you who are following us on the YouTube channel of JEE English can connect with us on the Telegram app using this link so that you're getting all the notifications of all the sessions and lectures happening here on the Unacademy JEE English channel on a regular basis. Okay. Now, with that, I'll take your leave. And before I leave you, this is my code. Let me remind you one last time. So, if you plan to get your Unacademy subscription, you can use the code RDLive and enjoy a 10% off on all your subscription. All right. So with that, I'll see you next with where we will carry forward this discussion, today's discussion, day after tomorrow. Okay, in our next class for class 12. Okay. All right. So you guys take care of yourselves. Keep practicing. Keep studying very hard. Okay, and take good care of yourselves. Right. I will see you day after tomorrow. Then bye bye.